thank you very much for the introduction. It's an absolute pleasure to be here and an honour to be a keynote speaker today. I began my career in construction 40 years ago, and as a young structural engineer, I looked at how we could build sustainably, and I never really felt like I had a good answer to that. I couldn't see how we could use resources and ever be sustainable. And I searched for an answer, and now I feel like we have solutions. So I've been inspired by a photographer called Ed Botinsky. He's a Canadian photographer who photographs landscapes where we've had a big impact. These are oil derricks in America. Oh. There we go. I think I'm going in the right direction now. And this is open cast coal mining in China. And looking at the construction materials that we use and thinking about the off-site impacts, these are redundant marble quarries, and we use marble in construction without really thinking about the impacts of where it comes from. It's open cast mining, so there's very difficult conditions for the workers, and a lot of dust is generated, so it's really an unpleasant environment to work in. And I can't look at marble in the same way after looking at these photographs. And then copper. When we first started mining copper, the intensities that we could find in the ore was 15% plus. Now it's down at decimal places. At the same time, the demand increases, so there's an exponential increase in the amount of materials we have to mine. And then this image, possibly one of my favourites from Ed Botinsky, beautiful but also very thought-provoking in its very stark contrast. These are nickel tailings, and I wanted to know, what do we actually use nickel for? It's a key component of stainless steel. And we take stainless steel almost for granted. We use it almost every day, and we specify it in our buildings. And I couldn't quite relate that to construction until over the last 5 to 10 years, we found shortages of sand for construction and apparently abundant material. And these shortages in construction materials led to big price changes, particularly in things like mass timber. And so it makes construction very volatile in terms of building and pricing. And these are problems before we even address some fairly major problems in the built environment around carbon, 40% from the built environment. And about November time, every time I do a lecture, I use the World Counts website, and I take a quick screenshot to see where we are. And for the last 3 years, we've been pretty much on track for 43 gigatons of CO2 emissions per year. Perhaps one bright spot, the EU recently said that their carbon reductions are showing the kind of reductions, I think about 8%, to meet the Paris targets, but globally that's not the case. And I had the pleasure earlier in the year of attending the Buildings and Climate Global Forum in Paris, which was a breakout session from COP, specifically to look at the issues in the built environment and how we would meet carbon targets associated with Paris. And there I saw and heard lots of enthusiasm from nation states to develop plans and commit to develop plans that would lead to decarbonisation by 2050, but without very many plans actually in place. And at the same time, lots of ideas and lots of enthusiasm for how to solve the problem. But then at the same time, this is a carbon tracker that shows our progress towards net zero in 2050, and it shows since 2015 we've made no progress. So at some point there needs to be some rapid acceleration to meet these targets. And then according to the UN, by 2050, half the buildings we have then don't exist now, so we're almost doubling our building stock. And that's also, we're obviously talking about buildings, but in terms of infrastructure, there's a huge infrastructure gap from the World Economic Forum. But we also see with the tragic events in Spain that we're going to be building a lot of infrastructure just for climate resilience. So there's a huge amount of building in front of us. And then we have 4.2 billion people living in our cities, and that rapid urbanisation, largely unplanned, has led to some really poor conditions. So Sao Paulo, for example, and I find this astonishing, went from 2.5 million to 22.5 million in the period of about 50 years. That rapid urbanisation means we have 1.1 billion people living in inadequate housing. And if we're really serious about the Sustainable Development Goals, then we need to build housing as a basic need and all of the social infrastructure that goes with it. So the outlook is that we have a lot of things that we need to build for society. And then there's another 3 billion people coming to the planet by 2050. That in effect equates to 100,000 houses per day. And this is a carbon reduction strategy from Arup, who I work for, so I feel like I can talk freely about it. At the top of the chain is build nothing, which is hardly conceivable when you look at all the things we do need to build. But I understand it's in a very European context, and we should remember that we're in a European context, and a lot of the things we need to build are in the global south. But build nothing is not really a viable solution to a sustainable future, particularly when you look at social and economic sustainability. And then with all this building that we need to do, construction productivity has been flat compared to manufacturing, which increases in terms of productivity. Construction is well known to be historically flat in terms of its productivity increases. So we also face this challenge of building a lot of things, and construction isn't very productive, and we have all of the issues of carbon, sustainable material supplies and so on. So what can we do? What are the solutions to that? Well, one of the ways that we can build more sustainably in the future is modular construction. Off-site construction and modular construction allows you to be more selective about the materials that you choose, to deal with the waste streams, to build more quickly and efficiently. But at the same time, a lot of modular contractors have failed in their efforts. This is an example project from our New York office, Atlantic Yards. It's still with Shop Architects in New York. It's one of the biggest modular projects built, but there were huge issues with how to deliver this in terms of the contractors and the supply chain and so on. So the construction industry is still trying to solve this issue of how to do modular construction successfully. But if we can get this right, then we really can change the way we build things. And I would also suggest that because it's a component-based design, a lot of the ideas that you're working on in terms of digital printing, fabrication, optimizing components can be integrated more easily into modular construction. It also offers a route into deconstruction, which isn't currently planned, but could easily be, I think. So very simple component-based design, putting things together, being able to be very selective about each of the materials and the waste streams that come with it and the reuse potential. And I'm working at the moment with the Norman Foster Foundation and a contractor in Portugal to develop a modular housing system that could be expanded across Portugal and Europe. Their idea of changing construction, but a hard path ahead because modular construction is very difficult to bring to the market. And then off-site construction. This is a project with Richard Rogers in London, Leadenhall, cheese grater, fairly well-known project. With Laing O'Rourke, 85% of this was constructed off-site, so the cores were built in modules and lifted into place. The concrete floor plates were in panels and then stitched together. It's a steel frame, everything bolts together, fixed together. It's an assembly of parts. Whilst this wasn't designed to be disassembled, it could easily be, and that's the next step, that we design this for disassembly and then we can change it and develop it over time. Because a lot of these commercial buildings, design life of many of the components is under 25 years. So we can already see a future where this is reshaped and redeveloped. We can optimize our buildings. In the background here is China Zun, completed some 5 years ago with our office in Beijing. It's a 538-meter tall tower. Interestingly, in China now there's a moratorium on high-rise buildings of 400 meters due to efficiencies, which is good to see. So this could be the last of a kind. But by putting together all of the computer and software power that's available and linking programs, it's possible now to be able to optimize buildings like this to create the most value from the materials in terms of usable space in the building, but also to minimize the materials footprint of the building. And this is an example of a study from our office in Amsterdam to look at how much material you could optimize from, say, a standard fabricated component to a digitally optimized component that uses additive manufacture to put the material only where you need it. And the results are quite stunning, 75% less material if we can start to build components like this. And our office in Amsterdam have taken that a step further and developed and built a 3D printed bridge in Amsterdam, which I guess has seen the press in Europe quite well now. And then I'm really impressed by the efforts from ETH and from Philip Bloch and the 3D floor plates that he's been developing, using concrete only where it's needed in compression and reducing the material footprints. So this is a project, I think you'll hear from Annette, she's gone later in the conference. There's a competition win Cree Tower in Zug, which actually brings this technology from the lab and into a project, and the prototype I see has already been built. In London, we've been working with Laing O'Rourke, the contractor for Leadenhall, to develop similar systems. I might call this perhaps 1D printed. It's precast flat slabs, 10 centimeters thick, arranged in compression. Laing O'Rourke tell us this has been, well, we were with them when they did it, but very difficult to build and put together. So there's some development to do in terms of the precasting technology and how you build it. But in effect, this is replacing what would have been a 30 centimetre in situ slab, so 3 times as much material in our conventional solutions. So huge opportunities to reduce the amount of materials we're currently using in our buildings. So optimization is basic common sense, but it's still not going to solve all of our problems when the demand is growing so substantially. So that brings us to thinking about the idea of reuse, and particularly in a European context with a renovation wave. This project, now very well known from Lacaton and Vassal, is a real exemplar. It's a housing development. They've done 2, one in Bordeaux and one in Paris, where they're able to keep the residents in place. And one of the things you find when you look at these projects is that people want to continue to live where they live with the people they live with. So how do you upgrade and renovate these buildings? In this case, they added a bay to the building. And then this project's really caught my attention. It's a project in Canary Wharf in London. So Canary Wharf, built about 25 years ago as an office-led development. I actually think it's a very good development. But through COVID, people have started working in different ways. Companies have rethought their portfolios. HSBC are leaving one of the main buildings in Canary Wharf. It's a 200-metre tall tower. So what do you do with it? So Canary Wharf at the moment are completely rethinking what their development looks like, what their district looks like, and introducing ideas of mixed use into the buildings. And this is a project by KPF that we've supported to transform this tower. And if you look at tall buildings around the world, there's only been something like 10 buildings over 200 metres demolished ever. So these buildings are with us to stay. So how do we transform them and what do we do? And I think Canary Wharf perhaps could be an exemplar for the future. And we're being asked this question in all of the cities we're working in. So in Frankfurt, we're being asked to revisit buildings 25 years old, in Los Angeles, in Hong Kong. And this is another example from Sydney, Quay Quarter Tower with 3XN, where the existing building needed to be reshaped, refurbished. What do you do with it? In this case, we kept to the core and we built a new floor plate, so completely transforming the building. But not easy to do. As a structural engineer, if you've got a fixed core and you want to add something to it, any change you make, how do you strengthen it and how do you do it? These projects wouldn't have made sense commercially 10 years ago, but now things are changing. And I'm working with the Norman Foster Foundation and Norman Foster on rebuilding in Kharkiv, Ukraine's second biggest city. We're invited by the mayor to help develop a reconstruction plan. And in Saltivka, which is in the northeast of Kharkiv, there's a lot of Soviet-style concrete panel housing. So we're looking at how do you upgrade that, how do you maintain it. Again, the residents say they want to continue living in those houses, they want to continue living with the communities that they live with, but they want the housing to be better. And so we've just completed an international competition to look for solutions. One thing that stood out to me when we analysed these buildings, that by upgrading the building fabric, you can improve the energy performance by up to 70%. And in Ukraine at the moment, there's a huge rush to provide energy to power these buildings. But if we could somehow improve the energy performance, we'd really do a lot in terms of the supply-demand equation. This is a project in London, again, 25 years old, that we've been asked to revisit. Number 1 Triton Square, it's with Arab Associates. One important fact here is that we had all of the information on the building, and we had a lot of digital information on the building, so we were able to pick apart the building. Although it wasn't designed to be changed and disassembled, that's what we've been able to do. It was also in the era of large atrium spaces. So by infilling the atrium and adding floors to the top, we're able to keep the character and the architecture of the building, but double its size. And because of the data, we're able to look very closely at all of the components, take the facade apart, take it off-site to a pop-up site, refurbish and remanufacture the bits that were needed to change, put it all back together and then put it back on the building. With the stone quarry, we were able to reopen the old stone quarry, and by taking the stone off and mixing it up, we'll be able to create a new stone facade using all of the existing facade. And that to me suggests that there's a route to products as a service, which hasn't yet quite broken through into construction, but this idea that you don't own your materials, you pay for a service, and it's the service provider who comes and upgrades it, takes it apart, takes the pieces back. There are obviously some very well-known examples in the construction industry, but over the last 5 to 10 years it hasn't become lots. But I think there's an opportunity there, particularly with facades. And if we're going to be changing and adapting our buildings into the future, we should probably think about designing that in the first place. So this is an example from the London Olympics. It's called Here East. And it was basically the media centre, so it's designed with large capacity structure. Afterwards, it's been inhabited with these WikiHouse kind of 3D printed or 2D printed houses that you can just put together and use as working spaces. And we're working with, again, a modular contractor in Germany, or a startup, to look at building modules that will not just be for residential use, but for commercial use as well, so they could be used in all sorts of different typologies. And then back to Quay Quarter Tower, the atrium space is designed so that you can adjust and change that over time, which is one of the key issues in commercial spaces, that you can't change them, you can't connect floors, you can't subtenant them. But by making the atrium very flexible in that building, that perhaps provides that into the future. And if we look at where our carbon footprint is in our building, we recently made a study with the World Business Council for Sustainable Development, and we looked at a number of our projects and where the carbon was. In a well-designed building today, about half of it is the operational carbon, but the other half is in the materials. And about 30% of that is in the upfront materials, but then surprisingly, 20% of it is in the change of use over time in terms of material fit-out. So there's some real opportunities in designing our buildings more flexibly, being able to deal with materials as they come in and out of buildings over time, and developing the models that will allow us to do that. In terms of overall carbon, we'll probably get about 8% carbon impacts from steel manufacture, and about half of that is used in construction. And about half of that is used as reinforcement in reinforced concrete, and that's a technology that hasn't really changed very much. So again, I think big opportunities. Very well publicised. I think even the public know that there's about 8% of carbon comes from cement. So what are we doing about that? This is a carbon reduction strategy, comes from the Global Cement and Concrete Association, has been adopted by the industry. It shows a relatively modest reduction in carbon to 2030 before a deep dive to 2050. And that deep dive is based on a number of things, but one of the big components is carbon capture and storage. which I think for our bigger materials, steel and concrete, is probably going to be necessary. In there as well is around a 20 to 30% reduction in terms of the efficiency of our buildings, the material footprint. Some of the examples I've already shown point away towards how we might do that. And one of the projects I'm working on with David Chipperfield Architects in Stockholm, the new Nobel Centre, will be using cement from Heidelberg materials. They have the first, I think, online carbon capture and storage plant in Brevik in Norway. But this is what it looks like. So even with carbon capture and storage, there's a huge off-site impact. And they also have the opportunity of, since this is in Norway, ties into the oil and gas industry. So the carbon that's captured is basically pumped into deep mines that have been that have had oil and gas extracted from them. So we might solve some of the environmental impacts, but we have to be aware that we could be creating others at the same time. And so timber is an attractive solution. This is a B-Sky B building, built very quickly. It's 12 months from when they instructed us to build it to when they walked through the door, using timber, so fast construction, lightweight fast construction. And this is Vancouver Art Gallery with Herzog and de Meuron. In British Columbia, they have a wood-first policy, so you have to explore your design in timber before you choose other materials. And of course, British Columbia has a timber industry. But if we're not careful about the way we use timber, so mass timber, for example, and the way that it's used into the future, so we're storing carbon which could easily then be released back if we just follow the same trajectory as we have done with steel and concrete. So it's not clear, I would say, that timber buildings are automatically more sustainable than other buildings. And then when you look at the land use and the competing demands for land use, do we have enough timber to be able to use that as a scalable solution globally? If you look at the global demand for materials, I would suggest that we don't, and that we need to embrace all of our materials in different ways to make construction work in terms of materiality and sustainability in the future. It suggests that we need to increase the supply of biomaterials and timber into the supply chain in construction whilst we're decarbonising steel and concrete. And perhaps points the way to using more hybrid type construction. So timber concrete composites, been developing those in Germany. This is a project called H7 in Münster, one of the first timber concrete composite buildings. And I know you'll also hear from Roger Bolthauser. This project in Zurich, H1 won one of the Holcim Foundation Awards, a fantastic project, and I hope he tells you more about it. He also tells me they've used a lot of rammed earth in the project, which of course is very topical at the moment. As a structural engineer, I can't go to a meeting now with an architect without them suggesting to me that we should build it in rammed earth. So thank you to Mikhail Rausch for that contribution. But this is Hortus with Herzog and de Meuron, a project I very much admire. Uses the earth from the site in timber forms to create a timber earth composite. But we're still going to generate huge amounts of waste if we don't change the way we build. And in cities, probably about half the waste comes from construction waste. And whilst we're getting better at recovering it, it's mostly downcycled. I think about 90% downcycled. And that's aside from the issue of demolition. I looked across the skyline here yesterday and I saw 3 tower cranes. If I do that in most cities, I'll see tower cranes everywhere. And in Berlin, to get anywhere, I have to walk around a construction site. So we're constantly living in our bigger cities with demolition, and I find it amazing that we are prepared to tolerate that all of the time. So the idea that perhaps we're not demolishing, but we're recovering materials and reusing them in a kind of urban mining deconstruction type capacity. This project also won a Holcim award. It's in Winterthur with Bureau Bau in situ, who I've found very inspiring in their work and their efforts. They collected used materials to make this building, but very much as a labour of love. There was no system within which they could do this. I'm impressed by the work that Holcim are doing in France, looking at recovering building materials and concrete materials and then being able to use them and recycle them. This is one of the first projects, but it uses a lot of technology and at the moment perhaps not scalable, but it points a way to the future. And this is a project called KA13 by MAD Architects in Oslo, which uses 80% recovered materials. And in Norway they have a program called Future Built, which provides support to people who are developing sustainable projects, and I find the program very impressive. And then a study we did for a region in the UK, North East Yorkshire, looking at the material supply chain in the region. And the idea was to look at the business as usual house and look at potential biobuild houses and the carbon storage that that would offer, and to look at the region as a whole and then to plan and manage how you would grow those materials over time and then increase the supply of housing in the region. So the idea that we're able to gather our materials and manage the resource and actually improve biodiversity in a managed landscape to create the housing that's needed, I thought was a very powerful one. And if we can fit all of that into the basic principles of circular economy, so keeping our materials at highest value for as long as possible, perhaps we can start to solve some of these problems. And I created a prototype project in London, Circular Building, to explore how that would happen. And a lot of the projects I've shown you fit now into those principles. And at the time I was inspired by a number of people working on similar prototypes. Dirk Hebel, I think you will also hear from perhaps, with the project at Nest. Peter Van Asch and the People's Pavilion, the idea of just putting together the building, taking it apart and giving it all back. And Kasper Kudelge Jensen at 3XN working on a project called Circle House, which was looking at concrete components and using Pico connectors to put it all together and take it apart. And the idea of the circular building was that all of the components could just be put together and given back to the supply chain for remanufacture afterwards, creating no waste. The idea that all of those components would have material passports so you could track them over time and understand what was in them. And using the basic principles from the research by Stuart Brand of breaking the building down into layers, which has now become a very well-known diagram. But when he studied the issues that were created by buildings and their change over time, he appreciated that it was the interface, the shearing between the layers that was causing the problem. And I think that's what we see in our buildings. So if we can design our buildings perhaps with a more layered approach and think more about time, then we can facilitate circular economy and recovery of materials. And if we can manage where the materials are coming from, perhaps we can start to head towards regenerative design, whereas at the moment, what we're doing is having a negative impact. We're trying to do less harm, but the idea of regenerative design in that we could do more good. And so if I come back to our carbon reduction strategy of build nothing, I want to add this extra layer on top, which is build regeneratively. And I think if we can do that over the next 25 years, we really can change construction and make a difference. Thank you.